Okay, there's two objectives in this video. First one is to continue to use our square roots as an inverse operation to solve equations. We'll look at some more complex equations where you still want to use square root to kind of unsquare something. And then we also want to introduce something for the next round of equation solving called the zero product principle. So we'll do that at the end. So to start, this is an equation that we haven't solved together yet, but I would like to think that the big ideas of algebra are starting to be the kind of thing where you can use them in a novel problem, and a problem you haven't seen before. So the two things I want to take a look at is we could look at the new big idea in algebra, which is the fundamental theorem of algebra, which says when you're looking at an equation that has an exponent on it, that exponent will tell you how many answers you should expect. So one thing I'm thinking already is I need to find two answers somehow. The second piece of the puzzle is that when you solve an equation, you can always rely on kind of undoing PEMDAS, working the order of operations backwards, because the idea of an equation at a certain point is they started with an x value, all this math happened to it according to the order of operations, and the end result was 16. So we can start working off of that 16 and work backwards, not only using inverse operations, but also the opposite order. So those two things might actually lead you to be able to solve this equation without any instruction, but it's something we want to build some confidence on. So let's see how it actually looks. So first order business. The order of operations begins in this case with, well, let's see, they would have added 3, they would have squared it. So I have to unsquare it first. So I'll take the square root of both sides. Notice there's big plus or minuses, and that's because of the idea that the fundamental theorem of algebra says you need to have two answers. They have to come from somewhere. And the moment that you square root, that's the moment that you're going to lose the squared off of your paper. So it's a great time for you to put the plus or minus in there that you're going to get two answers. So that leads to x plus 3 on the left-hand side because of the inverse operations of squaring and square root canceling, leaving it just x plus 3. Right-hand side, you get the positive and negative version of the square root of 16. So you get a positive and negative 4. At that point, it means that there's two paths that this could go on. The first one is that the value of x plus 3 could be positive 4. And the second path is that the x plus 3 could be negative 4. Now, you haven't seen that before because in the last videos, the last step we had to do to get x by itself was to square root. So this line said x equals plus or minus 6, I think it was, and we were done. But if x plus 3 equals positive or negative 4, that's a different idea. Then you have to say, all right, well, that means there's two paths I could go on here. X plus 3 could have a value of positive 4, or x plus 3 could have a value of negative 4. And you might not need to write down both of those things to keep track of both of those. But I think as things get more complicated, it's good for you to see how to record keep. So from here, then, you have two simple little equations you can use inverse operations on. Subtracting 3 from both sides on this one, you end up with x equals 1. And subtracting 3 from both sides in a nice balanced way gets you x equals negative 7. So that means our original equation, x plus 3 squared equals 16, does have two answers. Those answers are 1 and negative 7. Both of them would result in 16 for that expression. Okay, let's look at a slightly more complicated one. And because it is slightly more complicated, we're going to keep track of how this order of operations working backwards is really what we're doing here. So you see that equation. I noticed that there's a lot of math happening on this side, and negative 3 is the outcome. So we can once again perform balanced operations where these kind of outer layers of this expression goes away until we're left with x. So to keep track of that, we'll take a look at PEMDAS backwards. So looking at the left-hand side and seeing all the things that have been done to x, subtracted 4 inside the parentheses, we squared, we did the exponents at that point, we then multiplied by negative 2, and the final step was adding 5. Like so many times before, adding 5 is the last thing that happened. That's the first thing we have to undo. So think of a good opposite operation for plus 5, and that's minus 5. Use that inverse operation on both sides, you'll get a new equation where the canceling has happened of the positive 5 and negative 5. And you're left with just the rest of the equation over there, expression, negative 2 times x plus 4 squared. And that equals not negative 93 anymore, but negative 98. So let's move on to the next piece of the puzzle, and that is our multiplication and division, since our addition and subtraction is gone. We have to figure out how to use an inverse operation to get rid of negative 2 times. Sounds like a job for divided by negative 2. We'll do that to both sides of the equation. We should know what's left on the left-hand side because there's some canceling and everything else remains. So that's x minus 4 squared. And on the right-hand side, negative 98 divided by negative 2, negative divided by negative is a positive 49. It's a good place to be because as we continue to work our way backwards through PEMDAS backwards, we now come across exponents that have to be undone, and squared gets undone by plus or minus square root. And looking at that as what we have to do to 49, that's not too bad, because 49 is one of those perfect square numbers. That's what you get when you square 7. So our right-hand side becomes plus or minus 7. The left-hand side becomes everything that's left when the inverse operations have canceled, x plus minus 4. And our last step would be to add 4. But again, because there's two values here on the right, you might want to take the time to write two equations. X minus 4 could be equal to negative 7, or x minus 4 could be equal to positive 7. Adding 4 to both sides, you get your two values for x. Once again, two answers to an equation at x squared. That fits the fundamental theorem of algebra. Okay, so that's going to be something that you're going to practice. And then this next piece is something I want to introduce. You won't be doing practice with it too much right now, but it's to hold back, it's to keep the next video from getting too long. So it's called the zero product principle, and we'll break it down into its parts. First of all, zero product means 0 is the answer to a multiplication problem. And the rest of this thing is called the principle. And a principle is just like a foundation for reasoning. So apparently, we're going to be able to build some reasoning, some logic off of a recognition that 0 is the answer to a multiplication problem. So that works a couple of different ways. Numeric examples, we've done things like this forever. 5 times 0, 0. 37 times 0, 0. 9/35, horrible number. But times 0 ends up equaling 0, because any number in the world times 0 is going to equal 0. No copies of 37 is nothing. Looking at some variable expressions, maybe simplifying 0x could be thought of the zero product principle, because 0 times anything, even x, gets you 0. What else? Solving an equation. Now, we could use inverse operations here to get rid of 25 times. Or we might use logic and say, well, if 25 times x is equal to 0, the only way you ever multiply and get 0 as an answer is if you're working with 0 as part of your question. 25 is not 0, so I guess it must be that x equals 0. It's starting to build towards this logic you can use for zero product principle. And then there's no hiding from it anymore when you look at this equation. Now, I want to be honest, outright. You've worked so hard in learning how to get rid of parentheses. It might be really tempting right now to distribute that x, because we know how to do it, and get x squared minus 4x. And you would come up with a true equivalent equation, x squared minus 4x is equal to 0. But the fact of the matter is, you'd be further from solving the equation than you are right now. And that's going to play out over the next day or two also. But let's just take a look at this in the context of the zero product principle. So the zero product principle can be thought of two ways. Either, first of all, 0 times anything is always going to equal 0. Or the only way to get 0 as an answer to multiplication is if one of these things or both of these things are 0. So I had kind of thrown out an idea that a lot of students would throw out. Let's distribute the x and get x squared minus 4x. But that's going to make you now have to figure something out about x squared minus 4x. And there isn't a problem we've done together yet where x and x squared are both in the problem, and we've somehow been able to solve the equation. We haven't been asked to do it, but we don't know how to do it. Right now, if you think about this, the only way to get 0 as an answer to multiplication if it's 1 or both of the factors are 0, you actually are on a logical standing. You've got a principle that says either x is 0, or if x isn't 0, then x minus 4 is 0. And saying that out loud, like, what am I supposed to do with that? Seeing it on paper is a whole different story. If x is 0, well, you just solve for x. And if x minus 4 is 0, that statement, written as an equation, is a really simple little equation to solve. You can add 4 to both sides and get your second answer. So your two answers would be 0 or 4. That is going to be something we're going to work on in a little bit, but we're going to mix it in with factoring. So I just thought I'd introduce the idea of the zero product principle. It's got a nice ring to it. It's got a pretty substantial name. So when I start saying zero product principle, where we're going to try to get is, let's have a multiplication problem on one side, 0 on the other side, so we can use logic to deal with simpler equations. So reviewing our objectives, let's see what we got. We continue to use square roots as an inverse operation for solving equations, along with other operations we had to work backwards through. And then the second thing was we just lightly introduced the zero product principle. So if that's the end of it, then that's the end of the video, and we'll see you next time.